Okay, on this one, we are given two sides instead of a side and an angle. We're given two sides, and we have to find two missing angles and a missing side. Okay, so if I want to find side A, I'm going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So in this case, we have a squared plus 6 squared equals 12 squared. So a squared plus 36 equals 144. Take away 36 from both sides, we get a squared is 108. So a would be the square root of 108. And so a would be equal to the square root of 36 times the square root of 3, or in simple radical form, 6 square roots of 3. So our missing side is 6 square roots of 3. Now if I want to find missing angles, in this case I have, let's say for beta, we have an adjacent leg and we have the hypotenuse. Adjacent leg and hypotenuse indicate that we should be using the cosine ratio. So the cosine of beta is equal to the ratio of the adjacent leg to the hypotenuse, so 6 to 12. So the cosine of beta is equal to 1/2 if we reduce. And then if I want to find beta, I got to get rid of the cosine, so we take the cosine inverse of both sides. These two cancel out, so I'm left with beta is equal to the cosine inverse of 1/2. So my calculator tells me that the cosine inverse of 1/2 is 60. So beta is 60 degrees. And now that I have two of the angles, I don't need to go through and use a ratio. I could, but I don't need to find theta, because we know that these three angles have to add up to 180. So 60 plus 90 plus theta has to equal 180. Or 150 plus theta equals 180. Take away 150 from both sides, we get theta is 30 degrees. Now there's some other shortcuts. You may have recognized these ratios and been able to figure out that the angles were 30 and 60 just by recognizing the ratio of the sides. Or if you know that this is 90 and this is 60, you could just take 90 minus 60 to get theta. Those are all alternative ways, but this works for all kinds of triangles. So there you go. Example 4.